Okay, our first official u substitution problem is the square root of 2x minus 1. This isn't just the square root of x, so we can't just use the power rule on it. It's the square root of something more than just x. So again, we're going to use our u substitution on this, and the first step is always to identify u. So let's let u be the inside, which in this case is 2x minus 1. Step 2 would be take the derivative of both sides, so we would have derivative of u with respect to x. Well, the derivative of 2x plus 1 or 2x minus 1 is simply 2. Step 3 is solve for that dx. Again, we're going to do our cross multiplying, multiply both sides by dx, divide both sides by 2, and I'd end up with dx equals du over 2. We look here and we need to substitute in for dx into our problem, and we also need to substitute into u for our problem. So step 4 is rewriting that integral in terms of u and du. So this is going to be the integral of, instead of the square root of u, I'm going to go ahead and write it as u to the 1/2, and then instead of dx we have du over 2. So this one was really close to that nice direct substitution, but we do have that constant multiple that we need to worry about. The 2 is on bottom, and be careful, do not pull out the number 2. You're actually pulling out a constant multiple of 1/2. Be very careful with that. That's an error I see on the test all the time. So that would be 1/2 times the integral of u to the 1/2 du. So what do we do now? Now, step 5, we can actually integrate it because it's in terms of all u's. This would be 1/2 times the integral of u to the 1/2. Well, the integral of u to the 1/2 would be u to the 3/2. We add 1 to the power. Then remember it's divided by 3/2, but that's the same thing as multiplying it by the reciprocal, which is 2/3 plus c. Simplify the 2's here, and we're ending up with 1/3 times u to the 3/2 plus c is my simplified version. Again, with integration or anti-differentiation, I do not care if you change it back to radical form. So leaving it with a fractional exponent is perfectly fine here. That's what I'm going to do. So let's just do the final step, and the final step again is back substitute for u. So go back and look and think of what was u in the original problem. This is 1/3, u was 2x minus 1 raised to the 3/2 plus c. And that should be our final answer here. Now the informal step that I don't grade you on, but you absolutely should do every single time, is check your answer. So I'm just going to call that like step 7, right? And that's check your answer. How do you check your answer? You just take the derivative of whatever your answer was. So in this case we had 1/3 times 2x minus 1 raised to the 3/2. Again, the derivative of plus c is 0, so I'm not going to include that. Constant multiple is 1/3. Drop the power, so that would be 3/2. The inside stays the same, so that's 2x minus 1. The power minus 1, 3/2 minus 1 would be 1/2. But then you got to remember that we have to multiply times the derivative of the inside. Well, the derivative of the inside is the derivative of 2x minus 1, which is simply 2. I look at this and I look at, for simplification, my 3 simplify, my 2 simplify, and I end up with 2x minus 1 raised to the 1/2 power, which is exactly what the original problem was. I know I have the correct answer. Okay? Let's keep on going. Let's look at the next one. Example 5, it says change of variables. Again, you can go on and download the Wolfram CDF player and download this packet and look at this. You could also look at the graph. If you care about it, you could look at the graph on Desmos, but that's not really necessary. Let's just go ahead and work through this together. Again, this is x times the square root of 2x minus 1. So this one's a little more difficult. I want you to work with me here. So here, let's look at the first step. So what we're going to do is we're going to let u equal the inside of the function. In this case, it's 2x minus 1. Sorry, let me clear that up, 2x minus 1. Step 2, again, is going to be take the derivative of both sides. So when I do that, I get du dx would be the derivative of 2x minus 1, which is simply 2. And then again, step 3, I'm going to solve for that dx. Well, if I cross multiply both sides by dx, divide both sides by 2, I would have dx equals du over 2. So now the idea is I want to go in and I want to substitute in for dx, and I also want to substitute in for u. So when I do that, let's see what happens. We are now on step 4, which is substituting back in. When I do that, I'd have the integral of x times, instead of the square root of 2x minus 1, this would be u to the 1/2. Okay, there's u to the 1/2. And then instead of dx, it would be du over 2. Okay, what's going wrong here? Well, what's going wrong here is I still have an x and u's. My x's didn't all simplify. So the question is, did I make the wrong u substitution? Usually the answer to that question would be yes. In this case, the answer is no, you did not make the wrong substitution. You have to do some more math. If you know u equals 2x minus 1, you could add 1 to both sides and you would have u plus 1 would equal 2x. Divide both sides by 2 and you would have x equals 1/2 u plus 1/2, if you want to look at it like that. So what's the idea here? I just divided each term on each side by 2. Okay, so now the idea is not only do I need to substitute in for u and dx, but I actually have to substitute in for x as well. This is a really tricky problem. This is a very, very, very good test problem. Almost always teachers, including myself, put something like this on the test. So please make sure you check this out. So this would turn into the integral of, instead of x, it would be 1/2 u plus 1/2, right? And then we have u to the 1/2, and then we have du over 2. Okay, so let's see what's going on here when we go ahead and we distribute that. Well, the first thing that I realize is we could pull out, well, I don't want to do that. I'm going to distribute first. So I'm going to do u to the 1/2 over 2 times 1/2 u. So that would be u to the 1 times u to the 1/2. If you add the powers, you would end up with u to the 3/2. And then 1/2 times 1/2 would be 1/4. So distributing that u to the 1/2 over 2 to the first terms, I would have 1/4 u to the 3/2. Now let's distribute u to the 1/2 over 2 times the 1/2. And that would be plus, and then it would be, and sorry, I still have the integral here. That would be 1/2 times 1/2 is 1/4, and then we'd have u to the 1/2, and then of course this is all du. Well, I noticed both of these have a factor of 1/4, so I could go ahead and pull that out in front. That'd be 1/4 times the integral of u to the 3/2 plus u to the 1/2 du. Okay, it's a lot of simplification, and that's a lot of back substitution. It's a nice tricky problem for you. Again, this almost certainly will be on your test, so I need you guys to pay attention to this problem. Now we can move on to step 5, which is actually integrating. So this would be 1/4, well, what's the integral of u to the 3/2? Well, 3/2 plus 1 is 5/2, right? So that'd be u to the 5/2 divided by 5/2, which is the same thing as multiplying it by 2/5, multiplying by the reciprocal, plus u to the 1/2, the integral of u to the 1/2. 1/2 plus 1 is u to the 3/2, so that would be u to the 3/2 divided by 3/2, but that's the same thing as multiplying it by 2/3. Of course, we have our plus c. So we're almost done. We're one step away. The only thing we need to do is try to simplify a little bit and back substitute for our u. So if we back substitute for our u, I'm just going to go ahead and put our answer in the answer blank. Remember, u is, in this case, 2x minus 1. So what I'd have is 1/4 times 2/5. So that would be simplified, that would be 1/10. And then u is 2x minus 1 raised to the 5/2 plus, and then I have to do 1/4 times 2/3. So 2 divided by 4 simplifies to a 1 and a 2. So 1/4 times 2/3 should be 1/6, if I did my math correct. And then again, u is 2x minus 1 raised to the 3/2. Of course, we need our plus c. Don't forget your plus c, or I do have to take off credit. So this problem could be written numerous different ways. I could have factored out 2x minus 1 to the 3/2. There's absolutely no need. I'm perfectly fine with you leaving your answer like this. An answer like this would get you full credit on the test. So don't try getting fancy and going any further. I can't see the book right now, but I'm sure in the book they probably go a little bit further, or at least write it in radical form. Leave it like this, you're getting full credit on my test. Okay? So again, really tricky on that one. You make your u substitutions, you do your integration, you realize there's still this x here, but you do have the possibility of solving for x and substituting in for x as well. So we actually ended up substituting in for 3 things on this problem and then integrating. Nice, tricky, definitely on the test. Okay, let's look at the next problem right here. So this comes through practice. How are you going to get good at these? Truly, honestly, practice. So we have a sine squared of 3x and a cosine of 3x. So I'm going to look at whichever one is brought to the highest power. So on this one, I'm going to let u equal the sine of 3x because the sine is brought to the highest power. What does that mean? I go on to step 2. Step 2 is differentiate both sides. So if I differentiate it, it would be du dx. Well, the derivative of sine of 3x would be cosine of 3x, but then the derivative of the inside would be multiplying it times the 3, so that'd be 3 cosine of 3x. Again, step 3 here is solve for dx, so that would be dx equals du over 3 cosine of 3x. Just multiplying both sides by 3x, or 3 cosine of 3x, and dividing both sides by dx. Okay, we move on from that one, and we need to substitute in for dx, and we also need to substitute in for u, and let's see what happens. So when we do this, we would have step 4. The integral would turn into the integral of u squared instead of sine of 3x squared. That would be u squared. We still have the cosine of 3x, but then we multiply it by dx, which is du over 3 cosine of 3x. When we do that, notice the cosines of 3x is simplified. We have our constant multiple of 1/3, so I'm going to pull that out in front. This is going to be 1/3 times the integral of u squared du. Well, that's easy enough to actually integrate now. This is 1/3 times the integral of u squared, which is u cubed over 3. Then we have the plus c, right? So I'm getting 1/9 times u cubed plus c. That lets us move on to step 6, the last step, which the only thing we have to do is back substitute for u. And remember, u was sine of 3x. So this is going to be 1/9 times the sine of 3x quantity cubed plus c. Or you probably see it written, if we want to use the same notation as the book, it would be 1/9 sine cubed of 3x plus c. So it depends. Either of those notations, perfectly fine. You're getting full credit either way, but that's what it is right there. Again, how do we know we're right? You should check your answer. I do want to see the work for this. It would be 1/9 times 3 sine squared of 3x times the derivative of sine 3x, which would be cosine of 3x times 3. That would give you your 1/9 times 3 would give you a 1, and you'd have sine squared of 3x times cosine of 3x, which is exactly the original problem.